Okay. So I think I can hear you guys now. I think you can hear me. I think we can see what's happening. Confirmation. Like you could hear me yet? Yes, that's great. Thank you very much. Okay, and that was, oh, thank you. All right, 150 points just occurred. Yeah, 200 points, 250 points. It's 250 point wait. And I'm only exaggerating my tone. I'm not right. That's great. Thank you. Yes, so I see the 5 chat. Thank you, Stephen. Thank you, Casey. Thank you, Rain. Thank you, Sarah. Thank you, Dirkel. Okay, awesome. Right. So we're gonna continue the way we've been going. Like more and more, hopefully it's just clear that I owe you guys stuff. Anything that you've turned in, sorry. Can I put the Zoom? Oh, yes, absolutely. Totally legitimate question, Steve. Yes, in fact, yes. Okay, right. So thank you, Stephen, for what you put in the chat. It totally counts by that. And I know you're not doing it for this reason, but just again, to clarify to anybody else, like Stephen's just asking me to put the Zoom link in the classroom. Clearly somebody needs it, and clearly not Stephen, otherwise he couldn't be added, blah, blah. Just so you know, that's something he could write down for like a homework, for a class participation submission into the portal and get 50 points for. Again, I know that's not why he's doing it, and I know he's getting 50 points other ways anyway, but let me pause for a second to do that because I understand why that's important. I know now there's like a way I could directly just put that in the name of your class. I'm not sure, but I will put in yes. Hang on. So everybody bear with me for a second. Oh, well, I'll tell everybody though, while I'm doing that, we're going to continue with this way of like where I'm throwing out questions to you guys, and they're all these questions I'm throwing are coming from the homeworks. Like I'm just trying to stay with the homework issues in class. I'm throwing them out to you guys. We move on when we get them right. You totally get points for participating, as you are getting used to, for right, and you get extra points if you say things that are subject to being right or wrong. Get just reminded, but also I just want to clarify, because I'm going to ask you guys to work on this question while I'm going to distract myself. I'm going to put the Zoom link in the classroom, but the question we're going to start with today is right here. And I'm going to explain to you all how you can still retro get points for last week if you weren't here or something. I'm totally going to explain that, but the question to work on physics-wise right now is write down the assumptions that are right here on the board. You know, it's a new equation. If you've done, you would recognize this from some homework, but whether you recognize it or not does not matter. Just write down as a given d2 capital D dt squared equals negative 256 capital D. Like I'm introducing capital D. But I'm putting this in the, I'm going to forget to put this in the link. Oh, I mean, in the thing. Hold on. I'm so sorry. 1 second. Sorry. Wait, there it is. Okay. Okay. Sorry, everybody. All right. Totally legitimate question. Put the Zoom link in the classroom. I just did. I think there's also a better way to. So I just did. So thank you, Stephen, for that. I know people are in the waiting room right now. I'm going to let them in. Hold on. This is why I never try to do anything right, because you try to do one thing right, and it turns out like everything in the world has to be done right, and do that, not me. But oh, weird. Oh, I see. Okay, no, that's the best I can do for that link. I just put it in there. I thought, okay. Now let me tell everybody, there's this physics question that I'm about to ask you. I haven't actually asked it yet. I'm telling you the givens. The givens constitute a new equation where for the first time, unless you actually looked at one of the later homeworks, for the first time I'm using capital D as a variable right now. It's a little bit unusual because we usually like to take our variable names from the end of the alphabet. That's a tradition, but it's just a tradition. There's no reason. Capital D could be a variable, and I am using it as a variable here in this equation. I'm using it as a dependent variable. If you want to picture in the back of your mind what I'm picturing in the back of my mind as I write this equation, and if you saw one of the homework called heat harmonic, you might be able to follow this. I'm actually picturing that D stands for temperature. I'm picturing some kind of like temperature system somewhere in the world, like a weather system. a bunch of clouds or something like that, where the temperature is changing over time and following this equation. Like we took a bunch of data, just imagine, and we called temperature at any given moment capital D, just for whatever reason. And we charted out all these temperatures for a long period of time in some region, and put all the data on the graph and found out from putting the data into a scatter plot or into Excel or into Logger Pro or something that the data fit this differential equation, which you've seen a million times before. We usually write in terms of X or Z or something. This time I'm happening to write in terms of D. So I'm saying, imagine that a bunch of temperature values called D fall. Oops, sorry. Yeah. And I'm totally about to explain the homework thing. Right. Sorry, totally. A number of things are, everybody's using the chat and the private chat very well right now, but like a number of things are happening. I'm sorry. Yes, I'm totally about to explain. I will explain in a moment how even people who weren't here last week or something could still benefit from last week's participation homework. I'm going to explain in a minute how that still applies to this week and going forward. I totally will. I just want to, now that I'm also trying to explain this physics question that's like that we're about to all do for points, I just want to finish explaining this and then I'm going to do that. But yes, I have this physics question here. All I have of it so far is the equation. Again, it's an assumption. I'm telling you, imagine we got it from the lab, that D follows this second order differential equation, that the form of which you've seen a million times before happens to be that the number after the negative sign here, I'm saying assume to be given as 256. Then I'm also saying assume to be given that D naught, like I'm making up a value for D naught. In other words, D at T equals 0, just assume that D at value 0, at T equals 0 equals 5. So the two assumed facts that I'm giving you all are those two. I'm going to ask you a bunch of questions about those two facts. And like last week, if we get the questions right, we move on to harder, questions that move us along in the material. But until we get them right, you're just going to keep discussing them. Now, the one thing I do, but I haven't asked the question yet, again, to everybody. These are the physics facts. If you're really on your game, if you've been trying to follow the homework or follow me, or you're getting a little bit more comfortable with this, you might be able to guess right now what I'm going to ask you about these facts. Like I'm going to ask not very surprising questions about this, but it's true, I haven't asked them yet. I'm going to ask them on the next page. One thing though, to everybody, hopefully you'll notice, just before class started today, I placed two more assignments in the assignment stream, two more of these class participation type assignments. One is called the game take 3 or something, and the other one's called like the game take 4 for right or for wrong or something. They're exactly like the two from last week. One you're going to use, all of you are going to use for anything that you say today at all, either vocally or you put in the public chat, you say any, okay, right. And so if you weren't here last week, you might not understand this or might not know this. I'm telling everybody right now, like if you say anything at all today in the class out loud, or you write it in the public chat, then first of all, like I'll commend you right then or try to, but whether or not I even remember right away that you did that, what any of you are going to do is once you've made a comment, you're going to write it on a piece of paper. And I know this is boring to those of you but you're going to write on a piece of paper. You're going to remind me, they're going to say, my name is Yaverbaum or whatever, my name is Rain, whatever. And remember today I said that thing about, D has to equal 47. Or I said that thing about, I don't understand how the phase constant works or whatever it was, you're going to remind me, you're going to submit for that homework take 3. And assuming you don't lie, and it's easy for me to verify, and I probably don't even have to, I probably will remember the same thing you remember, that you said this thing, you'll get the 50 points for the day for having submitted that automatically. That's today, that's for everybody. Then that's homework 3 for today. Then in addition to that, any of you, all of you, anybody who at any moment today makes any comment that is actually gutsy and specific enough that it leads me either to say that is right, like that's the right answer to this whole thing, or leads me to say that's wrong. And it doesn't have to be a final answer at all. It could be any step. Like you could say, well, I used the chain rule here and I did the chain rule like this. And if then I go, oh yeah, but actually you used the chain rule wrong. Like the chain rule is not that. If I say you're wrong in front of the whole class, which of course I try to be more polite about that and I hopefully won't hurt anybody's feelings, but if I say you're wrong in front of the whole class, you totally submit that for 50 points. And like you remind me on a piece of paper, I said the thing about the chain rule, you said I was wrong. So I'm submitting this to the portal number 2, the for right or for wrong portal. I'm submitting it because you literally said I was wrong. And it's not that you're arguing with me, you, the student. If I said you were wrong or I said you were right, either way, as long as you said something gutsy enough that it put you in a position in front of the whole class where I would either say that you're right or wrong, either way, whether it's wrong or right, you submit it to the second portal, you get 50 points. And I'm telling everybody, you literally you can submit it, you can double dip. Once you say something that is gutsy enough that it's wrong or right, you can first submit it to the first portal just because it's a thing at all. And then you can submit it to the second one for an additional 50 points for it being gutsy to be right or wrong. Now, that's today. What I'm now going to tell everybody, the new part, that a couple people remind me in the private chat, say you weren't here last week, or say you were here last week and you understood all these rules, but like you didn't say anything for whatever reason. I'm saying right now, still, you can use last week's portal. Like last week's portals still exist. They're still there. So anything you say today, you can submit to last week. And in other words, I know this is ridiculous and I don't think anybody's really going to do this, but if you want to be very picky but like you can literally, if you say if you say 2 different things today and they're both right or wrongish things, you can literally double dip both of them, one into last week's assignment and in other words, last week's assignment portal is not dead. It's not closed. It's still open. Don't lie or anything. But if you didn't say something last week, if you say it this week, you can count it, but then say another thing to also count for this week if you want. And so everybody can, I still don't have an exact system for anybody who's just super, super, super paying attention and super engaged, but never saying anything. I think that whoever those people are should privately somehow reach out to me and we'll figure something out. But anyway, it doesn't matter if you weren't here last week. Hopefully this will get clearer to everybody, but I'm basically just saying I want it to be clear to everybody. The main emphasis is every time you talk here, especially if I shut up, if you talk here, you get points for that. And it's like doing homework. And right now I'm still behind turning back your homework. So right now what we're all trying to do is learn as much as we can and say as much as we can and take as much advantage as we can of this time here, which is why I'm going to shut up. And it's right now, it's not even so much about what you do in between classes because you got other things to worry about then. But here and now, whatever you say, you're then going to record later for points, and it's retro. That's what I'm trying to say to everybody. Again, I'll try to make that if anything I'm saying right now is still not clear, you still can ask me later and I can explain later, because my whole point is no clock is meant to run out on any of you. You're not going to lose the opportunity to participate in physics with me. Like once you get it, how to participate, then you're going to do it and then you're going to be rewarded. So that said, the question that we're all going to work on right now, and again, whoever has anything to say, just say, but the givens are right here. I'll rewrite them on the next page. I'll rewrite them. So the givens are this. And again, the more you've been following me going over the homework, or the more you've been thinking about it even in class, the more this stuff will start seeming repetitive to you or exercisey, but it might still seem mysterious. I'm saying right now, given this, where lowercase d is where capital D I'm using as a dependent variable, you might even want to write that down. I'm counting capital D as a dependent variable here. I'm counting lowercase t as an independent variable. I'm saying assume that we know that equation that I just wrote just happens to be true about D. And again, in my mind, if you want to picture that D is like a temperature system that's doing this, right? Also assume that this equals 5. Now, by the way, I'm not putting in units. If you want to put in units, you could, all these units are like in Kelvin degree. They'd be like degrees of temperature. So if that helps you put them in, but if it confuses you, don't. I'm just like, this is a math problem in effect. Now I'm going to say, here's the questions. Okay, so this is my first question. Again, I'm going to ask a couple of other questions about this system. And again, I promise everybody, it is another exercise in the same format as that math methods homework sheet, which we're still technically, we finished a section of it. We're going to go to the next section of it next, but I want to drill this in I want to dwell on a part of it first. So this is from that, but this you'll see will move us along in the material. It's trying to show us where this is going in the physics to lab and stuff like that. But anyway, so I'm going to ask a couple of questions about this setup being this equation and this initial value. But my first question is based on this setup, how much time must pass for D, for that variable D, to cycle through one set of values. So what I'm saying is, you might, way to interpret this question is like, at the beginning of us measuring D, it's at level 5, according to this. Like the very first temperature we measure is 5. Then D apparently fluctuates in values, goes through all kinds of values. I don't know offhand what values it goes through, but I do know that I do know something about its second derivative, apparently. What I'm asking is, it's going to cycle through it's going to go through a bunch of values, and then I think it's going to eventually come back to 5. I think it's going to cycle through values. I believe that looking at the form of this equation, I have a sense that this thing is an oscillator. In other words, I think D is going to cycle through values, and I think that I have enough information to figure out how much time it would take one cycle of D values. In other words, what I'm really asking is, what's the period for this oscillator? I just want you to understand I'm asking for period in this slightly now abstract sense of how much period of time will it take the temperatures to fluctuate from 5 through some other value all the way back to 5 again. But I'm asking in question A, what's the period of this oscillator? So I will take any comments or anything or whatever you guys want to do. We're not going into breakout rooms, we're just going to be here, but we'll move on once we've solved this. So, and I will shut up. I will just quietly solve on my own. Okay, I'm just going to say, so I said it was going to be a couple of questions based on this. I've now added the second question, even though we haven't gotten the first yet. I've added the second because for some of you, it might be easier to go out of order. You can either do A, and then it might make it easier to do B, or for some of you, you might be maybe, hopefully, you're totally, not hopefully, but you might be legitimately stuck on A or think you're stuck on A. But then if I had asked you B, you might know how to do that. And it might make you realize how to go back and do A. So I'm saying these two questions. I'm not going to add any more. I'm adding this B again because I think it might be easier. But I will say, whatever's happening right now, like, right, we can't go on until we get these. Like, you will find if you're legitimately trying, or if you're looking for your notes or whatever, these are very answerable and based on only what we've done so far. It's not anything new. So we do want to work this out before we go on. So if there's any question about the rules or what's going on right now, please feel free to ask them. And again, that would count as points. But I'm looking at chat. Right. It's more of a first world problem thing. That's hilarious. I didn't even see that. Oh, okay. First of all, sorry, the whole Stephen thing is hilarious. I didn't even catch it until now. But now, okay, Lloyd, yeah, please go. Yes, please, or ask me or any. Yes, and that's 50 points even just saying that. But yes, Lloyd, please. Or I could not listen if it helps. Wait, where's Lloyd? Ah, yes. Right. So I think one thing. So I like Lloyd's question, and again, definitely Lloyd gets 50 points for that, right? Like maybe even a double dip. In fact, I'm willing to say a double dip. Sure. I mean, because it was yes or no, and I'm saying yes, he's right. And even if I said no, so like what he said, like yes, I'm saying this. I'm saying I'm giving you this, and he's. I think what he's in a way what Lloyd's asking is it fair to say that like this is like saying right, totally. Like it's just like saying one of these other second derivative things that we've said before. Only I put 256 in there instead of like k over m, or instead of omega squared, or something like that. And I put d in instead of x. But the question I'm asking is about d, not about x. So like what Lloyd is saying is definitely helpful, at least to me. Like he's on the right track, I think. I know. I mean, he is. Whether yeah. So you're trying to. So I guess or I'll even say one more. It's kind of like I know his question is a good one, or it's a double, it's worth 50 points and 50 points again, because in fact, his question, in order for me to answer his question, I'm almost forced to give you guys what seem to me to be hints, which means it's a good question. It's a hint motivating question. In other words, this, what I'm saying here, this is the given of today. I'm saying, yes, he's not wrong, and it's not a coincidence to think that it very strongly resembles, say, this, or even, actually, I'll do even one step better. It resembles something like this, right? And part of what I am trying to get everybody used to, like, and really is not a dumb question, because in a way, what's hard about math at first, in like 7th or 8th grade, what's hard about math at first is algebra, when you're getting used to like numbers, they say, by the way, everything you've been saying about numbers, like it doesn't have to be a particular number. We could just use the letter X, and that stands for any old number. And that's kind of a mind blowing. that sends a lot of people running from math right there. But then the next level is when you get into high school and college and you have all these X's and Y's standing for numbers, but you also have A, B's, and C's standing for numbers, and they stand for it in a different way. Sorting out through exactly which letters are doing what is hard. And I'm saying here, yeah, whatever we've been saying about Z, I'm now saying about D. And whatever we've been saying about omega, now let me look, I'm going to look, oh, there's a problem. Right, okay, well, fair enough. And I'm seeing some questions in the private chat, and some of the questions in the private chat are good. I mean, no, of course they're good. They're all good, but questions in the private chat are in a way good enough that I definitely want to answer them, but I'll also say if they were in the public chat, I would not only answer them, but also give points for them. But like in terms of what we're asking for, what we're so I'm saying you're all looking at this, but I want you all to start relating it to what we've been saying in class. What we've been looking at class is this equation down here, the one in green. Or like at first we wrote it like this. At first we wrote it like this. Right, but what we're trying to get used to is even if those X's turn to Z's or D's or anything, even if those, like the X stands for a variable, but it doesn't have to be called X for it to be, to obey all the rules that variables obey. So what I've been trying to say in class is that first we have that equation written with X's, but the equation still means the same thing, even if it's written with Z's, or like today I'm writing it with D's. And the K over M part, the constants, it means one and the same thing, whether you write it as K over M or you write it as omega squared or you write it as some number, it still has the same power in that equation. So whatever we ever knew when we wrote it as omega squared, if that omega told you anything, if you knew what the omega was, any of you, I'm talking to, now we're getting, I'm looking in the chat. I think, super off. I think, okay, awesome. Okay, what Robert put in the chat. And sorry, so I was just responding. What I was just publicly saying was something inspired by a couple of private chat things. And I'm trying to tell everybody, if you sort of understand what to do with the omega squared in the green equation, then try to do the same thing to what we have here in the white equation. And that is what Robert, in effect, has done in the chat. Now, he definitely just said something that gets a double dip. That's definitely subject to right or wrong. I mean, first of all, he's got like an answer there. Now, to be totally honest, I think he might be off by a factor of, there's a minor point. Like I'm totally congratulating, totally psyched what Robert wrote in. I actually think the answer is pi over 8, not pi over 16. I think he might be off by a factor of 2, but of course, I might have made a mistake off by a factor of 2. He's definitely doing the right thing. I know what Robert is doing and he gets it. He's doing the right thing. I think he might be off by a factor of 2. I don't know. So I don't know if Robert, but I could be, we'll see in a second. But I don't know if Robert wants to say like where he got that or what he did, or if I should just put it in, but he's got the idea. But I think it's pi over 8 here. Well, here, in other words, or I don't know, Robert, do you want to elaborate or should I? Oh, wait. We don't need to, good question. For this exact question, part of the beauty is we don't need to integrate, partly because in a way we struggled with that at the beginning. We integrated to figure out this equation sort of at the beginning, but having done it once, we have figured out this equation. We supposedly now know how this equation works and we're just playing with different versions of it. So we don't actually have to do the integration again. What we're doing, okay, I'll do what I think Robert's doing on this and he can take over at any time if he wants. But here's what Robert's saying is this. You don't have to integrate. You have to look at that 256 and take the square root of it. That's what Robert is clearly doing. Oh, wait. Yeah. Right. Yeah. Right. Totally what Robert did. Right. And you don't have to take it twice. Good question. I'll show everybody. He did the thing. So somewhere either he or I dropped the 2 by accident. It might have been me. We'll see. But he's doing the right thing. And it looks like Lloyd's got, which is great. Again, both of them, please understand that they are getting like, they're doing what I'm asking. They get the points. And if one of them wasn't here last week and they said all this stuff, they could submit part of this for last week too. Hopefully you guys are getting that. Here's what they're doing though. They're saying, the thing that I will keep writing for the rest of my life, like that some of you might know that I've written many times in this class, but some of you might not because it looks slightly different each time. And also because no matter how many times I write it, I'm not writing it enough for any of us. Like, and also because every time I write it, it only means half of, it means more every time I write. Like this thing that I'm writing, D2Z, blah, blah, Z equals, what we're saying as the basically accumulated knowledge of this class for like the 4 weeks that we've been slogging through this stuff. And I know it feels like a slog, but the basic thing that we're like learning in the clunky way that it was learned to physicists in the history of physics is what we're learning is if we ever see a second order differential equation of this form, like some variable that is being treated this way in time, if we ever see that, then we know that the variable is oscillating harmonically with an angular frequency. In other words, then we know the variable, whatever the variable is here, in this case it's z, then we know the variable is oscillating back and forth, back and forth, back and forth at a rate which is, by definition, necessarily, not by definition, but because we've solved it, then necessarily z is oscillating at a rate which is the square root of whatever constant is in this equation. And that is why we write it as omega squared. Like it's all like benefit of hindsight, Monday morning quarterback. It's like weird until you get it, because half of what we're doing, we only started doing once we got it. And so then we retrofitted it. It is confusing. I mean, until you get it. But what I'm saying is if you ever see an equation that looks anything like if you see this, and then there's any variable here at all, like any variable, like a Q, right? If you see a Q there, in this second time derivative left-hand side thing. And then if Q is being related like this, if then you see the same Q variable on the right-hand side, but there's a negative, and then there's something constant in the parentheses. Now, and this is also where people fall off because what's in the parentheses could be written in a super complicated way. Like it could be, what's in the parentheses could be, it could look like K over M. It could look like some Greek letter. It could even look like a Greek letter squared, or it could look like some number, like 256. Whatever is in that parentheses, as long as it is not a variable, as long as whatever's in the parentheses does not have a Q, in this case, and does not have a T, right? Whatever's in the parentheses is not a variable, then whatever that constant term is in the parentheses, no matter how complicated its expression is, then what we're saying is necessarily the square root of that constant will be the rate at which this variable Q oscillates. Like that's what the meaning of all this math is. If I say if Q, blah, 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 then Q equals Q naught cosine omega t, sorry, what I'm trying to say. I'm trying to say cosine of square root of constant times t. That what we're always trying to say is that if you see that second order differential equation, as long as there's a t in the denominator, then whatever variable is in the numerator, it is oscillating at a certain rate. And the rate will, the angular rate, the number of radians per second will always be the square root of whatever is that constant. Like that is totally what, wait. Right. Right. And again, I'm looking in the, so now there's a couple more questions in the private chat, and they are thick and good questions. Like I have to read them. They're certainly attentive questions. Again, though, they'd be great if they were in the public chat because I think they'd benefit everybody. And then I also wouldn't slow down. But yeah. Right. So I'm saying we take the square root once, because the reason we take the square root once is, where did the square come from in the first place? The square is coming from two derivatives. Like we take, it's coming from chain rule being done twice. Like in other words, to everybody, it's like, and this is where the math methods homework that we were all doing together, I mean last time, like what the point, the math methods homework is sort of trying to show why this makes sense by going in the opposite direction. In other words, if I have something, this, say I have like Q equals Q naught. If I just try this function, right? Q naught times cosine of omega t. Omega could be anything, it's just some number, right? But if I take one derivative of this, and this is to everybody, again, I mean, there's a couple of questions in the private chat that lead me to want to clarify this to everybody. So, but please, whether it was your question or not, like I'm saying, notice if I take one derivative, the omega comes out once from chain rule, right? So I get negative Q naught omega sine omega t. That's one omega that comes out. Then if I take the derivative again, the omega comes out again. So this is what, but that's it. It's the only thing that comes out again. So it gets squared. And then one more line, and I can go back to this. But then I'm just saying, try something. Like, and I know, and again, just about, almost. Okay, the thing that Rain, okay, wait, yeah, the thing that Rain put in the chat just about seals the deal on what I'm saying. There's like a slight mistake in it that I do want to correct, but it's clearly it's 50 points without a doubt. And yes, it'll bring home what I'm trying to say. It'll seal the deal on what I'm trying to say. I'm just trying to say right here. And notice here again, by the way, where I might have lost 5 people just now is we're talking about a problem that involves capital D. I'm totally agreeing with like Robert and Lloyd and other people who are figuring out the problem by looking somewhere in their notes or in their mind at some equations that we have written about Z and X, even though here today the problem is about D. And the way I'm explaining what I did, which is going to totally bum some people out, is all of a sudden I'm talking about lowercase q. That's where I would be annoying some people that I keep switching like that. But I am doing it on purpose to try to get everybody eventually to see that what you don't want to get bogged down in is whether it's a capital D or a Z or a lowercase q. What I'm trying to show everybody is it's just the nature of a dependent variable. As long as the variable's in a certain place, as long as it's in the numerator of the derivatives we're talking about, then it, whatever letter it is, ultimately shouldn't bother us. So I'm saying here, if Q is a cosine function with its angular frequency in the parentheses there, omega, if you differentiate it twice, then the omega comes out twice and becomes squared. So you end up getting this second derivative of Q with respect to time equals negative omega squared times Q. Like because of that, that's what we're saying for all time. Like since that didn't rely on the nature of Q or D or Z, like it didn't matter. I mean, and this is part of, now I'm addressing another part of another private chat question. Like, yeah, in order to literally just figure out omega for this example, or to literally just figure out capital T, I'm completely agreeing with some people in the private chat. I'm completely agreeing and saying, I actually did not use the capital D or the Q or anything at all. Once I saw the form of the equation, I could trust, oh, D is oscillating at a certain rate. And yeah, I didn't even use the D to figure out that rate. I just said, oh, so if we were given, so now back to the problem. If we were told that this was true, sorry. If we're told that this is true, then I right away know just by seeing that, seeing like, oh, second time derivative of some variable equals negative times some constant times that very variable. Since I see that, I right away know what I right away know just by looking at it. And this is like, I know it only because of the last few weeks of class. Like I wouldn't know this because I was born knowing it or anything. But what the last few weeks of class are trying to show is that whenever you're walking through the forest and you walk into an equation that has that form, then we automatically know, we necessarily know, The thing that definitely, right, here we go. Here we go. And then what Rain and Durkel are doing in the chat is like so exactly like good, like trying to get straight from what I'm saying and trying to get like that's what I'm asking everybody to do. It's exactly right. Like they're trying to take what I'm yammering about and like focus it into like, okay, so does this mean blah? And they're both doing exactly the right thing. I think now I want to address what Rain and Durkel are putting in the chat and some other people in the private chat. Like what I'm saying is this, in other words, close, but I'm saying, I think you're off by square root or something. I'm saying if this is true, then simply, and remember we did say at the beginning, I had to give you also that D naught was equal to 5. If that's also one of the givens, then I think what we're saying here is, right. So I'm saying it's very close to what people are saying in the chat. But first of all, you don't include the negative. The negative, remember, you don't include the negative is not part of the 256. It's like negative parentheses D. Just like remember, this is all based, everything we're doing here comes from here. So what I'm saying right now is it all comes from Hooke's law in the first place. It all comes from Hooke's law. But the thing about, so, I mean, I'm really saying in terms of the, well, okay, I'll put in the chat exactly what, the chat is so the right idea, but it's not actually right. Now Rain, okay, I think Rain might be right. I'm going to check. Sounds very right. I actually didn't even do the math yet, but I think she's totally right. I think she's got it. I'm just going to type one thing into the chat in terms of what I think she said. So I am saying this just to correct. We're saying, see, yes, I think I do agree with, I think it's negative. Well, so this is what I still think she's doing the right thing. One second. I just want to make this as clear as I can to everybody. I just put two, again, everybody who said, I want to reemphasize, I think I just I kind of violated my own rule. I thought people were so close that I just gave the right answer to B, or basically I'm saying Rain was close enough that I gave the right answer to B, even though it is a little different from what Rain's answer was. Then I also, oh, cool. Oh. Oh, wait, so maybe all right, let me check one more time. Let me check. I may have done that. Oh, negative. Oh, okay. So I might be wrong with the 9. I mean, I'm rounding the 9 anyway, or the 8. But as long as you both agree, Lloyd and Rain, about the negative, that's kind of thing. Okay, I think we're cool on B. But I also realize now, I'm trying to be clear, so I may be over. I also just gave an answer to A, because remember, this whole discussion of B just evolved because we were talking about A. And like I predicted, for some people, it might be easier to see B first than A. But somewhere in here, I just put the answer to A in the chat. And actually, I hadn't actually shown anybody, like I hadn't even resolved yet whether it was me or Lloyd who was right or wrong by a factor of 2. So to try to be clear to everybody now, on the next page on the notes, I'm going to show you where I got answer A. I think these are the answers. And again, everybody's getting all these points, whether, whatever the answer is. But for answer A, oops, sorry. The first thing I'm saying about A, to backtrack now, to go back to A, I'm saying if we wrote down that second order differential equation, then 256 is the constant there. Like we have second time derivative of some variable equals negative times a constant times that variable. Like this is the equation that we're studying here. This is the specific equation for simple harmonic oscillation. Whenever it has that second derivative form and the constant and the negative sign, blah, blah. So we have that. Now, whatever is that constant, we always call omega squared. We always call the whole constant omega squared. We could just call it anything. Like it's just a constant. It's not a variable being squared. So we call it omega squared, and that confuses people. We could just call it omega, or we could just call it L or something, but we call it omega squared because what we're trying to remind ourselves is whatever it is the square of the radians per second rate at which the system's going to oscillate. Like that's the beautiful thing that we sort of found out 3 weeks ago, that the system will oscillate as like a cosine function, cosine of omega t, where omega is the rate of oscillation angularly, and that rate is the square root of whatever the constant is. In other words, we know right away just looking at this thing, this is all without integrating or anything, because we did all that work in the last few weeks. We know right away that omega is 16. Omega is 16. The square root of, wait. So to the chat, hold on. So I'm totally, wait. Okay, so this is what I'm doing right now to everybody. The questions in the chat right now are good, like pretty range, but this is exactly what I'm saying right now. Like the minute we write down the equation d2d dt squared equals negative 256d, what I'm saying is that 256 is automatic, whatever, I'm saying this to everybody, I'm saying, and I'll do this again in a second, and I'm going to say it more and more. Believe me, anybody and everybody, once you get the thing that I'm saying, then it'll feel like every time I say it, you'll feel like I'm bludgeoning you over the head, or that I'm repeating something obvious, or that I'm yelling at you or something. But it's not true. This is one of those things that nobody gets it until they get it. That's why I'm going to say it over and over, and I'm not mad or anything. I'm almost excited, because the more anybody gets close to admitting that they don't totally get this, then the more chance we're all going to get it. And it will seem much simpler once anybody gets it. And I know some of you do, but what does that mean? That A equals not quite. Does it mean A equals not quite? Oh wait, yes, it does. Well, it means the Casey thing, yes, but with a negative sign. Like it means. Yes, as long as you throw a negative sign in there, Casey. Yes, it does mean that. And I'm saying to everybody, right, once you'll know you got what I'm saying if you have a feeling of like, oh, okay, cool. And you see how Casey, okay, this is so funny to me in a good way. I hope she takes this in the right way. You see how Casey, right after she said that thing, she then wrote O-H-H, okay, right? Like, which is in the pot, like, who knows what her face looks like right now? Who knows? But the way she's saying like, oh, okay, you can almost see Casey going like, oh, it's that stupid. Like, I don't know if she's saying that she feels like I'm being stupid, having like spent this much time saying something so dumb, or if she feels stupid. No one should feel stupid, but yes, physics is always this way. All of you will know that you get the thing I'm saying if the first feeling you have right after you get it is like, oh, that's idiotic. Wait, that's all it is? That is what you'll feel, but don't be disappointed or mad. It always is like that in physics. But yeah, all I'm saying is whatever you see in that equation, that constant term, like don't include the negative sign. The negative has to be there for this to be Hooke's law. But whatever constant term comes after the negative is automatically, necessarily, for all time now, the square of what we call omega. Or put another way, omega for all time now will be the square root of whatever's in that thing. And again, that's a big leap. Like we just know that from now on because we put all this math work for the last 3 weeks into figuring it out. Like that's the idea. But I am literally saying now, so I'm saying to everybody, like, so here, back to this example, and we will do one more example out of this. Once you get it, again, you'll think it's so dumb, you can't even believe how much time, but it takes this much time because we wouldn't have the right to believe something so dumb and simple unless we waded through all the complexity of it. But here's, I forgot what I was just, here's, what the heck? Yeah, so if we have this, I'm saying that automatically we know, just by looking at that, then we know that this is the constant term. So it is automatically this. Like maybe more specific to those of you, if this happens to be a mass on a spring, that constant might be written square root of K over M, right? Like that's a constant, the square root of the stiffness divided by the mass. Like stiffness is one constant, mass is another, but divide one by the other, take the square root, and you have a constant. So the constant could be specific K over M, or maybe it's a pendulum, so the constant is like G over L, or maybe it's a temperature system, so it's some other thing that I haven't told you, but it doesn't matter because whatever that constant is, whatever that constant is, we know the square root of it is omega. And omega is number of radians per second. In other words, omega by definition is 2 pi over the period. So to wrap this up finally, I know I'm saying a lot of, but how did I get the answer to this? What I literally, part A, how I got it, and this go, and it is totally, again, it is what Stephen did from the start. I think it was Stephen. We could say, okay, and it was Lloyd too, we can say that, and this is where you and Stephen and everybody is just like off by one thing at the beginning. You, Lloyd, and everyone can say that the entire constant is the angular frequency squared. That's what I'm saying. It's the square of the angular frequency. The angular frequency is automatically the square root of whatever the entire constant is. That's the one big trick. That's the one big thing. Wait, correct. Yes, got it. You got it. You got it. Right, right, right. So totally. So in this case, I think you really do. And I'm really excited because this does take a long time to get. It does. And it takes people hanging on and feeling it would be worth it to keep hanging on. But once you get it, this is the heart of PChem, by the way. It's not just for us. Like this will never go away. And PChem, in some weird way, an instrumental, but definitely PChem, we're saying here, omega equals 16 radians per second because it equaled the square root of 256. That's where I got the 16. I literally just took the square root of that freaking number that was in the equation. But now I'm saying, but for all time, you know, or you could put it this way, like, what I just wrote fast, I just wrote like there's a million, I'll write this again on the next page, but then once you see omega is what pops out of the math. Omega is radians per second. It's what pops out of the math in this way. Like it pops out in the sense that it's just the square root of whatever's sitting there in the equation. But nobody, including us physicists and us mathematicians, we don't love radians per second any more than you guys do. Radians per second is what pops out of the math. But then when we do in our minds is we try to picture an actual physical situation that we can handle, like the lab or something. And we're like, what we would picture and measure in real life, we would measure how much time something takes to go across. Maybe we would measure how many times it went across per second. No one would measure radians in real life. Like, that's great. We're not any crazier than you. What we would see in the lab is like, oh, it's gone back and forth 400 times in a minute. Or, oh, it took 400 minutes to go one full lap. We would think in terms of standard frequency and standard period. It's just they're easy to relate to angular frequency. Okay, I'm gonna put it on the next page. Frequency is just angular frequency divided by 2 pi. In other words, just always remember, 1 cycle equals 2 pi radians, right? So if you're doing 4 pi radians per second, that means you're doing 2 cycles per second, right? And if you're doing 2 cycles per second, that means that it takes you a half a second to do a cycle, right? This is how we can so we've got 3 things, F, omega, and T. And as long as you know one, you know the other 2. They all mean and measure the same thing, F, omega, and T. They all relate to the same thing. It's just that one is the easiest to measure in the lab. The other is the easiest to picture in our minds. The other is the easiest to pop out of the mathematics. And so we just want to link between the 2. So in effect, like standard frequency is the link between angular frequency and period, between the math and the lab, so to speak. And in this case, what I'm saying here is, okay, then if omega here was 16, omega was 16 radians per second, that means frequency 16 radians per second over 2 pi 2 pi radians per cycle, right? And so then the radians cancel and you get 8 over pi cycles per second, which was not right. That's the frequency now in hertz. Like, granted, it has a pi in it, but so what? Pi is just a number. Like, if it's doing 16 radians every second, that means it's doing 8 over pi cycles every second. Did I say this back? Yeah. And therefore, its period is pi over 8 seconds per cycle. There's other ways you could do that. But that's where I got. And again, like I think it's right. I mean, I know originally Stephen, a lawyer, someone had pi over 16, but like as soon as I saw that, I knew they were doing something deeply right. They just divided by 2 one extra time or something. But yeah, for all to yeah, squared right. So the thing in the chat is right. No, I think this is progress. I think people are starting to get it now, and I really appreciate how honest people are being in the chat. I hope we're all trying to meet each other here. I hope you believe me that I will not, if you ask a question that you think I answered 3 days ago, that is not the thing I will punish anybody for or be upset about, because I really believe in my heart. I understand this stuff because I went over it so many times in my life. I don't think I understood any of this the first time. No, I know I didn't. I don't think I understood any of this the 5th time. So I cannot be upset at people for needing to hear something more than one time, even if they think they're not even paying attention. So when you get it. So the more people can ask about it and the more force me to say that okay. Therefore, what we're going to do is one more example, just like this one, just like it. So I think you'll get it a lot faster. Maybe I'll ask, for those of you who really are paying attention, but it's like just sinking in right now, I'm going to give another example just like this right now. So yeah, the negative, right. Okay, good question. Really good question. Let me answer. So Gabriella, and by the way, please, you definitely put that in for 50 points, Gabriella. That's awesome. I'm going to answer that. It's a great question. Let me say to everybody too, especially given that Gabriella just put that, I'm going to ask, after I answer her question, I'm going to ask another exercise just like this. Like, I'm really not going to make a twist or anything. It's just going to be another practice. So those of you who feel like you're really comfortable getting it, it's like sit back for a second and you could pat yourself on the back or make it harder for yourself. But hopefully some other people that are just starting to get it now, take a shot and try to answer or try to get the points. Like the other people will defer to you. Let me first say, though, to Gabriella and everybody else, right, the equation that we're looking at over and over again, everybody, and again, this also goes back to like 2 weeks ago when I think Robert said something about content. Like, it really seems like it seems like there's a million different equations and you never know whether what we're looking at is an example, is one example or many examples, but no, it's really one equation being written a million different ways. So I'm going to write it again today. Right now, I'll write it with, I'll say it with z's again. So z just means any variable, any dependent variable at all. Let's say I'm writing this down partly to answer Gabrielle's question, and also, there's supposed to be a z here. Right. Well, right. Like, so the thing about the negative always has to be in this differential equation. It has to be there. It's there in the first place because of Hooke's law. If it's not there, we're talking about if the negative is not there, then we're not talking about an oscillator. It's different physics. It's a whole different physical system. If the negative is not there, it's like off limits right? It's out of bounds for us right now. Like, doesn't mean it's illegal, but it's not the physics we're talking about. We're not responsible for it. We haven't even come up. I don't even know how to solve it. I mean, I do, but if there's no negative there, I'm not holding anybody here responsible for doing anything. We don't know it if it's not negative there. That's a different system. But whatever is here is necessarily positive. Like you'll never see a negative number in those parentheses. You'll always see a negative number outside. I mean, you'll always see the negative sign outside. Whatever's in those parentheses will always be a positive constant for this material that we're looking at. If we're talking about simple harmonic oscillation, which we are, like, it's still the chapter and all. If we're talking about simple harmonic oscillation, then the equation will look like this. And what's in the parentheses will be positive. So, and we're always only going to take the positive root of it. Yeah, like, so it can never be positive. Like correct. The equation, the whole equation can never be positive in this class. The whole equation will have that negative sign there. That's correct. But then the negative sign is part of the equation, not part of the constant. So the constant will always be positive in this class. That's right. And the square root that we take of it will always just mean the positive root, because the root refers to a rate. You can't, a rate of going back and forth. So yeah. So I think I'm saying to both of you. Yes. Yeah, and again, let me say to those are good questions. So I'm going to give, those are good questions. We're going to give this last exercise for the last 5 minutes right now. I'm going to give it, I want to say also, again, anything that anybody's put into the public chat or the discussion, you'll just remind me, you'll submit it tonight. If you said 4 things today, you know, two of them you could submit for last week, blah, blah, blah. But I also just want to say, again, almost every question I got today in the private chat was good enough for me to want to stop and acknowledge or help out. Like, it did help me understand where the class was. It did help me say something. Everything I got in the private chat. I'm saying that because I'm not giving points for the private chat. I can't, because if I set up a reward system for the private chat, then people are going to use it the wrong way. Every question that someone put in the private chat today could have gotten points, would be good for the whole class to see. And I see why people think they'd be embarrassed, but please don't. But I do have to, and I'm not trying to punish the private chat questions, but I can't give points for the private chat questions, because then everybody would put things in private chat and then I could never move forward and teach to everybody. All right, so I'm just saying this to everybody. What I really want you guys to use the private chat thing for is something like, I need an appointment with you, Yaverbaum, or I sent you an email, you didn't respond yet, or I need a college recommendation, a graduate school recommendation, or blah, blah, okay? Like there is a real good, especially because I am bad with email, it's very fair to put in the private chat, Yaverbaum, please, I sent you an email, can you please, like, I hate that, it means I screwed up, but that's fair. That's what the private chat, but then I'll like have to deal with it. I don't want to deal with it with the whole class. But if it's physics, please guys, put it in the public chat and you'll get points and everybody, but anyway, all that's all to say, everything I've got in the private chat today was a great question. And luckily almost all those people also put things in the public, so they'll get all their points. But all right, that said, here's my last just practice exercise review. If you really think you've got this, you can hop off, or you could test yourself. But I'm just saying, let's say now, so on a new page, let's say, and I know we have 3 minutes, but let's say D to Z. Oh. Okay, now I didn't put in units. The units could be anything. But I'm saying, let's say d2z dt squared equals negative 121z. That's a given. I'm just saying it. I'm also saying, let's just say it's a given that z naught, like the value of z at t equals 0, equals 4. I just made that up. Those are two independent facts, but you do need them both. Then I'm asking, and you could do these in any order, and I know we have 3 minutes, but I'm asking find capital T, which means the period of this oscillator. It is an oscillator. If you look at that equation, you can tell this is an oscillator. So I'm saying right away, find the period of it. By the way, I could have asked find the frequency, be the same. Oh, cool. Oh, cool. And I'm not even looking at chat yet because I think I think you guys are rocking it. It's great. And then I'm saying at lowercase t equals 1, find the value of z. I was about to say I would just write out the answers. Okay, but let me look at the chat. Looks like people have already nailed it. That's great. All right. Awesome. I totally agree with Ms. Kim, and thank you, and good, because we didn't hear from Ms. Kim before. So Ms. Kim just got double dip 50 point. Well, yes, Ms. Kim, the T is 2 pi over 11. I totally agree, and that was really fast, and that's awesome. So you get points for having said anything at all. You totally get another 50 points for saying something that I could say right or wrong about, and I am saying it's right. So please submit both of those. Ms. Kim, that's awesome. And then Rain, awesome. I love how fast, I am almost 99% sure that I totally agree with you, but you're so fast, I haven't checked it. So I'm just going to check and then we'll all go. But I think I'm totally praying for rain here, obviously. Not praying for rain. Praying for, you get it. But hold on. So she did the, oh yeah, 2 by 6, 0.28. Wait, I think, okay, right. So I do agree with Ms. Kim. Oh, and by the way, whether to express it Ms. Kim's way or Ms. Roberts, like Rain's way, either one would be fine. If there's like whether you express it with pi, unless I specify, if you put it with a pi, you're being exact but immeasurable. If you put it with chopping off digits, then you're being measurable but not exact. We do prefer measurable in physics, like the way Rain wrote it, but either way would be fine. Now, I actually think though that those are two. I thought Rain was actually solving for. Yeah, I think honestly that Casey's right that that for capital T, which is 2 pi over 11, 2 pi is basically like 6. So it's basically like 6 over 11. So it's a little bit more than 0.5. I do agree with Casey for part T. And Dirk, cool as well. This real, right. Well, right. Now, cool. The one last answer then. So A, yes. So I think there's a computation error, or it might be the calculator is in or something for range. But I definitely agree with 0.57 or 2 pi over 11. And now lastly, for part B, which also be what this might be the part that Rain's actually doing. For part B, cool, very cool, awesome. This is great. And again, all of you guys submit these, and I feel like, and again, if any of you feels like you're starting to get anything, then please don't ever say to yourself, oh, but what I'm getting is obvious. I should have known that all the time. Don't say that. Or don't say, oh, what I'm getting is like the stuff from 3 weeks ago. So now I'm 3 weeks behind. Or Yaverbaum is 3 weeks behind because we should be, as long as you're getting something, then we're progressing, all of you, for real. And it works like that. But okay, maybe to calculate, fair enough. So I'm just going to quickly, so that we can wrap up. It may very well be the calculator. I'm going to do, or maybe that we're just confusing units that were B. So A, I think omega equals square root of 121, which is 11. So T equals 2 pi over 11, which is about that. I think this is right. But then for B, we're solving for Z. Now we're solving for Z equals Z naught cosine. Like this is, and we just know this because we've solved this oscillator. We could check this by differentiating twice the thing I just wrote, but we know it at this point. In other words, Z equals 4 times the cosine of 11 times T, right? And for part B, what I was asking for is, what is Z when lowercase t equals 1. Remember, lowercase t is the variable time, capital T is the specific amount of time one cycle takes, i.e. period, i.e. a constant. But so we want this. Now this part here, this also may be where this part, what I'm writing right now, and we're finishing on this. And again, just keep going, whatever homework you just, I think you get it. But this part I'm writing right here, I am doing on my calculator. I do not do the cosine of 11 in my head. I do not. I do it on the calculator, and I make sure it's in radian mode, which it is. So it's cosine of 11 radians times 4. And that's, and maybe this is what, and I think I know, I see what's happening on your Yeah, 2 pi over 11 is right for question A. For question B, now just to, you get approximately 0.01. 2 pi over 11 is right. But if you put 2 pi for part A, but if you put in 2 pi over 11 in your calculator and get 0.28, what's happening, I can tell you exactly what's happening. What you're doing is 3.9. What? Wait. Yeah, okay. Good. Rain. Awesome. Yeah. The 0.0178 is the answer to B. You're totally doing that correctly, Rain, and everybody else. That's awesome. Yes, exactly. And the 2 pi over 11 thing, those of you, when you get, if you say 2 pi over 11, that's correct. But then if you put in your calculator and you get 0.28, it's because what you're doing is doing pi over 11 times 2. Like you're not putting the parentheses or the order in correctly. If you get 0.28, what's happening is the way you're typing it or the kind of calculator you have, you're getting pi over 11, like 3 over 11, which is like, like less than 0.3. And then you're multiplying that by 2 and getting like 0.28. You want to do 2 pi, just get that on your calculator. That's like 6.28. And then divide that by 11, like 6 and change divided by 11 is okay. All right, cool. So I think this is great. Seriously, guys, like again, and the more times I ever say someone's name, everybody should know, the more times I'm saying someone's name, that's just good for them. It's just good. Even if they ever feel like I'm often saying their name and then saying something that is not what they think or something, if I know your name, it's just good all around. So thank you all. So I think but I think you're also knowing calculus more, all of you. So let's just keep going. God bless, electron bless. I will see you in 2 days, and I'm going to end. And I'm going to post all this, I promise.